the superposition theorem. So superposition theorem states that in any given linear network consisting of multiple sources, the overall response at any given point in a network is equal to the sum of the individual responses, with each of the sources acting independently while the other sources are being made inoperative. Now I'm not going to do the derivation for this. I will in simple way explain you how to apply this superposition theorem to a circuit. Now this statement says that you have to consider each of the sources acting independently, right? So it is applicable to only independent sources. Okay, it could be independent voltage source, or it could be the current source. So superposition theorem is applicable only to a independent voltage source or a current source. That means you have to make them inoperative. That can be done only if the sources are independent, otherwise it is not possible. Now how to make it inoperative? Okay, to make it inoperative, if it is a voltage source, we consider it as a short circuit. Okay, if it is a current source, we consider it as a open circuit. Okay, so any circuit, if you want to make the sources inoperative, if it is a voltage source, make it as a short circuit. If it is a current source, make it as a open circuit. So remember this, superposition theorem will be applicable or very useful when there are independent sources, many independent sources, not just one independent source, many independent sources present in the circuit. It could be a current source or it could be a voltage source. So you can see in the question they have specified that you are supposed to compute the voltage V, that is marked here, right? So this superposition theorem is applicable only when you have multiple sources. Okay, multiple sources. So the question or the example in which I have given, you have totally three sources, two voltage sources, that is one is 6 volt, another one is 8 volt, and you have one single current source which is of 2 amps. What we need to do is, we need to consider these sources acting alone, making other sources inoperative. Okay, so let us begin with this 6 volt, and we have to make all the other sources inoperative. And I told you how to make the sources inoperative, right? If it is a voltage source, make it as a short circuit. If it is a current source, make it as a open circuit. So let us consider three cases because we have three different sources. So in the case 1, I will consider the 6 voltage source acting alone. Let me draw the circuit and see what I get. So this is 6 ohms. I have 2 ohms resistance, and I need to make other sources inoperative. So this voltage source, I told you, right, when this is made inoperative, this will be considered as a short. Then I have a 3 ohms resistance. The voltage V, I will now name it as V dash. Okay, and the current source will be converted into an open circuit because this is to be made inoperative. And then I have to consider only the 6 volt voltage source acting alone. Next, what we need to do is, we need to just apply mesh analysis to the circuit and solve the numerical. So consider the two mesh currents. This is I1, this is I2. Write the equations for the two meshes. So on applying KVL to the mesh 1, I have this as minus 6 minus 3 times I1 minus 2 times, this is my dominant mesh, so it is I1 minus I2 is equal to 0. So this equation I can rewrite this as minus 5 I1 plus 2 I2 is equal to 6. Let me name this as equation 1. When it comes to mesh 2, I can write the equation as this is plus, this is minus, this is plus, this is minus. So this is minus 6 I2 minus 2 times, this is the dominant mesh, so this is I2 minus I1 equal to 0. So rewriting plus 2 I1 minus 8 I2 is equal to 0. So solve these two equations and see what you get the value of current I1 and I2 as. So the value of current I1 is minus 1.33 amps and the other one is 0.3 amps, right? For us the value of I2 is not that much to be worried because we want to determine what is the voltage V dash in this case, right? So if I have to compute the value of current V dash, right? So what is this voltage V dash? This voltage V dash will be the current multiplied with the resistance, and the current is from negative to positive, so this will be minus of I1 into the resistance that is present here. So this is minus of minus 1.33 into R. The value of R is 3. This is equal to, so this is 3.99 volts. So we have determined only for the first case what is the value of voltage V, which we denoted it as V dash. Why V dash? Because we have done only one case, right? Now let us do the same thing with the second case. In the second case, I will consider 18 volt acting alone and 6 volt and 2 amps are inoperative. So what we need to do is make this 6 volt as a short and make this 2 amps as an open circuit and solve. Again apply mesh analysis itself. Case 2. So in case 2, I am considering 18 volt acting alone. So I have to consider the 6 ohms resistance, 2 ohms resistance. This is 18 volt. 6 volt will now be a short. Then I have resistance 3 ohms plus minus. Current source will now be considered as a open circuit, right? Now this voltage V, I will name it little differently as V double dash, just because I need to differentiate this, right? So this will be V double dash. Now apply mesh analysis and find out the values. I will name this current as I1, this current as I2. So apply KVL to mesh 1 and you get this as, this is as per the direction of current, this is plus, this is minus, and this is plus, this is minus. So this is equal to minus 3 times I1 minus 2 times, this is the dominant mesh, so this is I1 minus I2 equal to 0. So I can rewrite this equation as minus 5 times I1 plus 2 times I2 equal to 0. I will name this equation as equation 3. Apply KVL to the second mesh. So this becomes plus minus plus minus. So this is minus 2 times I2 is the dominant mesh, so I2 minus I1 minus 6 times I2 is equal. So this is 2 times I1 minus 8 I2 minus 18 becomes plus 18 on the right hand side. So this is your equation 4, right? Correct. I just want the value of current I1 because V double dash will be obtained only if you know the value of current I1. The value of I1 is equal to minus 1 amps. Now to obtain the voltage V double dash, it is going to be, this is positive as per the polarity that is specified. This is plus and this is minus, right? The polarity that has been specified. But the direction of current is opposite. So when you write the Ohm's law, V double dash would be equal to minus of current I1 into the resistance, that is 3 ohms. So minus of minus 1 into 3, which is equal to 3 volt. Then coming to the last case, case 3, where you will consider only the 2 amps acting alone and the remaining 2 voltage sources are inoperative. 2 amps acting alone. So if it is a voltage source, it has to be made as a short. This is 6 ohms, 2 ohms. This is going to be a short. 6 volt is also going to be a short. 3 ohms. This is plus minus V triple dash. Now I will represent it in triple dash, and this current source is here. So you have in total 3 meshes. So apply the equations for the mesh currents I1, I2 and I3. So write the equations. From mesh 3, you can see this current source is exclusively to this mesh. So I can write the current I3 to be equal to minus 2 amps because the direction of the current source is opposite to the direction of the mesh current. When I apply KVL to the mesh 1, I get the equation as minus 2 times I1 minus I2 minus 3 times I1 minus I3 equal to 0. So I can write this equation as minus 5 times I1 plus 2 times I2 plus 3 times I3 equal to 0. I know the value of I3, right? That is minus 2 amps. So this becomes minus 5 times I1 plus 2 times I2 equal to 6. This is my first equation. So when I apply KVL to the second mesh, the currents have to be considered plus minus plus minus. So this is minus 2 times I2 minus I1 minus 6 I2 is equal to 0. We can write this as plus 2 I1 minus 8 times I2 is equal to 0. Name this as equation 2. So solving the two equations 1 and 2, I get the value of current I1 to be equal to minus 1.33. Now if you look at this voltage V triple dash, the current that is flowing across the resistance 3 ohms is having an opposite polarity with respect to the current I1, right? This current I3 is fine, but current I1 is opposite, right? So I can write this equation for voltage V triple dash as equal to I3 minus I1 into 3 ohms, or I can also write this as V triple dash is equal to minus of I1 minus I3 into 3. The result will be the same. Whatever you do, V triple dash is going to remain the same. You get this value as minus 2 volt. Now the superposition theorem says that you have to compute the value independently, right? of all the sources acting independently, but the resultant will be equal to the sum of individual responses, right? So in the case 1 you got V dash is 3.99, in the case 2 you got V double dash as 3 volt, and in the case 3 you got it as V triple dash. So finally the result of the value of voltage V will be equal to V dash plus V double dash plus V triple dash. So this is equal to 3.99, the value that you obtained in the beginning. Second one, the value was 3 volt, and third one the value was minus 2 volt. So the final answer is 4.99 volt. So here is another example. We will try to solve this. The question says you need to find the value of current I using superposition theorem. How many sources are there? You have one voltage source and you have two current sources, right? So in total there are 3 sources. And all these sources, if you observe, are represented in their polar form. So it becomes difficult for us to do the calculations because these sources are represented in the polar form, whereas the impedances corresponding to the inductor and the capacitor are represented in the rectangular form. So to make things simpler, convert these sources from polar form to rectangular form. Okay, so let us see what would be the value of the voltage. 8 angle 135 degree. So 8 angle 135 degree is equivalent to minus 5.656 plus 5.656 J. Then you have 2 angle 0 degree, which is the current source, this current source, and this is equivalent to saying this is 2 amps. The value of this is in volts. This is 2 amps. Then you have 2 angle 90 degree. Convert this and see what is the value that you get in the rectangular form. 2J, right? This also is the current source, so the unit will be amps. Now you need to work on these 3 sources: voltage source, current source, and this is also another current source. Each of these sources have to be considered acting independently while the other sources are inoperative. So let me consider first the 2 angle 0 degree amps acting alone, and the remaining 2 sources, this voltage source and this current source, is inoperative. So if it is a voltage source which is inoperative, then you need to make it as a short. If the current source is inoperative, it has to be made as a open circuit. So case 1, I will consider 2 angle 0 degree acting alone. So draw the equivalent circuit and see what we can simplify this to. So you have a current source. Now I'm going to write the value in rectangular form. This is equal to 2 amps. Then you have 2J ohms. So this voltage source is now going to be a short. You are having 2 ohms resistance. Capacitance value is minus J ohms. And this current source, when you make this as an operative, this is going to be open circuit. So in total you have 2 meshes. Now this is mesh 1 and this is mesh 2. This is an open circuit, right? So let me denote the current that flows across this. I'm going to denote this as I1 and this current as I2. So use mesh analysis and compute. Now in the question they have specified you to find out the current I, right? And they have marked where the current I flows. So it is this current that flows Now for each of the cases I need to compute the value of the current I. So let me denote this current I for the case 1 as I dash. So use the mesh analysis and try to solve this case 1. So if you look at the mesh 1, from mesh 1 I have the value of I1 is in sync with this current source, right? So I1 is equal to 2 amps. For the mesh 2, so when I apply KVL, this is plus, this is minus, plus, minus. So this is going to be minus of minus j into I2 minus 2j into the dominant mesh is this one. So this is going to be I2 minus I1 equal to 0. So try simplifying this. Substitute the value of I1 as 2 amps and see what do you get the value of I2 to be equal to. So this becomes plus JI2 minus 2JI2 plus 2JI1 equal to 0. So this is equal to minus JI2 plus 2JI1 equal to 0, or I2 is equal to, when you bring it to the right hand side, this also becomes negative. So this is minus 2J into I1 value is 2 amps divided by minus J. So this JJ gets cancelled and the value will be equal to 4 amps. What we want is the value of I dash. So if you look at I dash is in sync with the direction of the current I1. So I can compute the value of I dash to be equal to I1 minus I2. So this is I1 is 2 amps and I2 is 4 amps. So I is equal to minus 2 amps. In the case 2, consider 2 angle 90 degree acting alone, and in the case 3, consider 8 angle 135 degree acting alone. So for the case 2, I will redraw the circuit once again. In the case 2, I am considering 2 angle 90 degree acting alone. Right? So I have to redraw the circuit. So I had the inductor across which the current was flowing. The value was 2J. Then I had a resistance 2 ohms, capacitance whose value was minus J, the current source, that is 2 angle 90 degree, and I'm supposed to make the other sources inoperative. So in this case, the other sources, one is the current source. So whenever you have a current source, this current source has to be made as a open circuit, and the voltage source, when you make it as an inoperative, it is supposed to be made as a short circuit. So again you have two meshes. I will name this as mesh 1, this as mesh 2. And for my simplification, this current I, now I am going to represent this as I double dash. Okay. So this current of mesh 2, I will call it as I2, and this current I will call it as I1. Because you have a current source exclusively to that particular mesh, I can specify corresponding to mesh 1, I1 to be equal to, we got the value of 2 angle 90 degree, right? 2 angle 90 degree is equal to 2J. The direction of mesh current I1 is opposite to the direction of the current source. So that is why the value will be equal to negative. So this is I1 equal to minus 2J amps. Now apply KVL to mesh 1. KVL to mesh 2. Write the equation. So when you write the equation for mesh 2, you have the direction of current is in the clockwise. So this is plus minus, this is plus minus. So this is going to be minus minus of J into I2. This is the dominant mesh, right? I2 minus I1 minus 2J into I2 equal to 0. Solve this. Substitute the value of I1 and see what you get I2 equal to. So this is plus JI2 minus JI1 minus 2JI2 equal to 0. Minus JI2 is equal to this is J times I1. I1 is minus 2J. So I2 will be equal to 2J. JJ is JJ square, right? So 2J, this negative sign goes off, 2J amps. Now you need to find out I double dash. So I double dash is what actually in this case. I double dash is the current that flows across 2J, and they have given the direction, right? And this current I double dash is opposite to the direction of the current I2. So I double dash is equal to minus of I2, which means I double dash is going to be equal to minus 2J amps. For the case 3, what we have one voltage source that we have to consider, and these two current sources have to be considered as open circuit. So connect the voltage source, make the two current sources open circuit, and then solve. So that would be your case 3. So case 3, 8 angle 135 degree volt acting alone. So you have an inductor. This is 2J ohms. This is open circuit. You have a resistor, that is 2 ohms. Capacitor minus J ohms. This again will be an open circuit. Whenever you have a current source, if it is inoperative, make it as an open circuit. And now connect the voltage source here. This is plus, this is minus. 8 angle 135 degree. Okay. So if you observe, these are both meshes which are open circuited, so you cannot apply KVL here. So the only mesh that you have is this mesh, right? And how was the direction of this current which was specified to be computed? It was like this, right? So I will name this as I triple dash. So this is the only mesh that is present here, M1. I will denote the current of this particular mesh as the current I1. So this is plus, this is minus, this is plus, this is minus. And 8 angle 135 degree we have computed in the rectangular form, that is minus 5.656 plus 5.656 G, right? So this is the value. Apply KVL to this. This is going to be minus of 5.656 plus 5.656 J. This is the value of the voltage, minus this value, that is minus J into the current I1 minus 2J into the current I1, which is equal to 0. So when you solve this, you get this as, this is plus J, this is minus J. You get the value of the current I1 to be equal to, when you take it to the right hand side, this becomes minus I1 into minus of minus 5.656 plus 5.656 J divided by J. So I1 will be equal to, the negative sign goes off, right? This is divided by J, so the value of I1 will be equal to 5.656 plus 5.656 J amps. So this is the value of the current I1. What we want is I triple dash. So I triple dash is what? It is the current which is opposite to the mesh current I1. So this is going to be minus I1. So this is equal to minus of 5.656 plus 5.656 J amps. So this is what you get. Now in the superposition theorem, as I have told you, the statement says you are supposed to find out the result by adding the sum of all the responses. So individually we have computed what is I dash, what is I2, I double dash, and what is I triple dash. We have to find out the current I, right, in this circuit. We have computed individual responses. So the final result is the sum of all of them. So the current I is going to be equal to I dash plus I double dash plus I triple dash. So this is I1, we got it as minus 2 amps, I dash is minus 2 amps, I double dash is minus 2J, I triple dash is minus 5.656 plus 5.656 J. So the value of I will be equal to, compute quickly and tell me the answer, minus 7.656 minus 7.656 J. Imaginary terms and real terms are added. Sources can be made inoperative only if they are independent sources, not otherwise. Okay, only independent sources can be made inoperative. Other sources cannot be made inoperative. If they are dependent sources, whether it is a current source or a voltage source, you can't make them inoperative. So whenever you have a dependent source in the circuit, when you are applying the superposition theorem, that should not be touched. It has to be kept as it is. Okay. So when you make inoperative, make sure that it's an independent source. Voltage source will be made as a short and a current source will be made as an open circuit.